Hi everyone and welcome to part 7 of this video tutorials. In this video we are going to save mesh data from 3MF importer and send it to graphic cards for drawing. Alright, so let's start by adding a simple structure inside mesh data header files, and let's call this structure MeshData. Okay, so here is our structure, and inside this structure we have a container that holds the vertices as well as the container that holds the indices for our meshes. Okay, and that's pretty much all we need for now, and let's go ahead and create a new class for drawing our meshes and sending this data to graphic cards for drawing. Alright, so here is the code for MeshModel class that we use for drawing 3MF mesh models. Here, as you can see, we are deriving from mesh draw interface, and we obviously have to implement a draw, send data to GPU, and update matrices functions. Let's take a look at the CPP code. So as you can see, we are also passing mesh data object to the constructor of this class, which we then pass to send data to GPU function to be sent off to the graphic cards for drawing. Okay, so inside our update matrices, we are also updating our model view projections uniform. And inside our draw function, we are drawing things by using GL triangles, and we are passing the size of indices and the type of indices that we have. For now, let's use GL unsigned int for the indices. And we also have two additional functions that obviously return the number of vertices and triangles. Alright, so that's all we have inside this class, and hopefully you found this very simple. And let's go ahead and inside our import 3MF class, let's add some code to store the data that we want. Alright, so here inside our import 3MF class, we now have a new public method called MeshModels, which returns a vector of mesh models that we want to draw. Okay, so as you can see here, we have a MeshModel share pointer, which we stored inside pMeshModel, and MeshModels is also a container of this pMeshModel. Alright, so that's all we have inside this header file, and let's go ahead and take a look at inside the CPP file. Okay, so inside the CPP file we have a new method called a getUnitScale, and we basically we use this to convert the model units into a centimeter. So as you can see, inside this method we have a switch statement that takes the model unit and converts it from foot to centimeter, or from meter to centimeter, and so on. And to find out these numbers, you can actually go to Google and let's type foot to centimeter. So 1 foot is 30.48 centimeters, and that's the number that we put here. 1 meter is obviously 100 centimeters, so if you go to meter, you can see that we have 100 centimeters, and all this conversion you can easily do them and come up with these numbers. Okay, and basically if you look at a 3D model file, you can see that at the model element we have the unit, and this in this case the unit that we have for our cube is millimeter. So if this is a millimeter, we want to convert this to centimeter. And the reason we do this is we basically want to be consistent with our units that we have inside our application, and you will see in a moment how we actually use this getUnitScale function. Alright, so the next method that we have is called save mesh data per item, and this is a very important routine that we have inside here, and that's basically where we are storing our data and save them in our containers. So before we go inside this function, let's take a look at and see how we are calling this function. So if you go all the way down inside our read data method, you can see that every time we are iterating through these build items, we are calling this save mesh data per item, and we are passing our P model as well as our mesh and the container that we want to populate our data. Alright, so let's go and have a look at our save mesh data per item and see what we are doing inside here. Okay, so the first thing that we want inside this function is to create an object of mesh data and populate it with some data. So as you can see, we create our mesh object and we populate its data all the way from here to here. And once we are done with that, we simply create a new mesh model, and we pass in our mesh data to this mesh model constructor. Alright, so by this time we have created our mesh model, and once that is done, we simply store it inside our mesh models container. Alright, now let's go ahead and see how we are actually storing our positions. So we basically iterate through all of our vertices that we have. So these are all the vertices that we have, and we create an object of vertex. Okay, and we can simply get the node by calling the get node and passing the index, and we can get the position of these vertices as we saw in earlier videos, and we simply store them in our vertex position. Once this is done, we store it in our mesh data vertices container. Now, in this video, we are not storing colors because we need to also parse in the base materials. And in the next video, we will see that how we are actually parsing our base materials. And once we do that, we can simply store our colors. But for now, let's stick with positions only. Now, to store our triangle indices, we need to do a few things. The first thing that we need is to find out the type of information a triangle has. And I'll show you in a moment what I mean by this. So we start by creating a mesh information handler object by calling get mesh information handler. We store the pointer to this object and we call it pmesh information handler. We also create a new pointer called p-information, and the type of this pointer is cmesh information. Now, every time we loop through our triangles, we want to make sure that what type of triangles we have. So we can call the pmesh information handler and call it a get information by type, and this function basically takes enum. By looking at the CPP, you can see that this enum is called emesh information type. So let's have a look at this information type, and these are pretty much all the types that our triangle can have. Okay, there are some types such as EMI abstract, composite materials, last type, or multi-properties. We are not interested in any of these types, and there are three types that we are interested. One is called EMI based materials, and the other one is a node color, which is simply a color RAM or color group, and as well as texture coordinate, which is the textures. Okay, so what this means is if we take a look at our 3D model for our cube based material, you can see that the only type that we have here is a base material. So all of these triangles that we see here, they have a type of base materials. Okay, and that's what we are actually checking here. We are checking to make sure that these triangles that we have here have base materials assigned to them. Okay, if this triangle has this data, so we can call p information face has data and pass the index to this. If it has that data, then we go ahead and we store the indices for that particular triangle. Okay, so Hopefully this makes sense. Let me show you another model that I created called Cube Mix. And let me open this up with 3D Builder. And as you can see, this cube comes with a mix of texture and color group. Okay, there is no base material in this case. And let me put the wireframe so you can see the triangles. So these two triangles here have textures, and the rest of them have color groups. Okay, now let me close this, and if we go back to Cube Mix folder, 3D model you can see that. Let me put this inside here so we can see things better. Let me also close these windows. Okay, so here is the 3D model for our cube mix, and as you can see here, unlike the cube base material, we don't have any base materials here. The only things that we have is the color group and texture group. Okay, and if we go through our triangles here, you can see that the first triangle that we have here has a PID 6. So we go ahead and see what PID 6 is. So it's a color group. So that means that this triangle has color group associated with that, and these are the indices for this particular triangle. Okay, which means we go through this PID 6, and the first vertex has this color, second one has this color, and the third one has this color associated with them. As you go and look through these triangles, we can see that this particular triangle has a PID 7. Okay, so if we look at PID 7 here, we can see that this is in fact a texture. Okay, and these are the coordinates that we have for these triangles. All right, so as we saw, there are only two triangles that have this PID, and we can see them here. So this triangle and this triangle, these are the ones that have textures associated with them. Now, if we were to actually load this 3MF in with the current code that we have in import 3MF, we would probably crash or never able to load this, because our code does not handle color group and textures at the moment. Okay, and this is not the intention of this video series. We only want to deal with base materials for now. Okay, so if you want to load your models, make sure that they only have base materials and no texture colors or color group assigned to any of the triangles that it has. So with that said, we are pretty much done with our import 3MF class. There is nothing else inside here, and we are now ready to actually go ahead and load some 3MF files with base materials and see if we can draw and see them inside the app. Alright, so we are now inside our main app class, and we now create import 3MF as a unique pointer, and we save it inside this class because I want to call this object inside the draw function as well. So inside the draw function, we simply loop through all of our mesh models that we created inside our import 3MF, and we call the draw function for each one of these meshes. We also pass in the camera and our current vertex shader to this mesh as well. Now, as you saw, we are not actually setting up the colors for our vertices, so when we run this code, we should probably see just a black color, and that's okay for now for this video. So let's go ahead and run CMake since we added some new files here, and let's run this. And inside Visual Studio, we reload all, and let's compile and run our code to see if we can actually see something. So again, we are loading our cube base material, and let's run this code. Okay, and it seems we have some compiler issues. Okay, we need to actually include vector here. Alright, so everything is good, so let's run this. Okay, and we don't see our cube inside the app. That's great. Okay, so where is the cube? Let me close this, and if we go back into our 3D model, you can see that we are not right now we are not actually taking into account the transformation that we have for item, and probably our object is outside of our camera range. So for now, let's go ahead and move our camera on the z-axis a little bit. So I'm just gonna set this to 14 and maybe move this a little bit up as well. Or maybe let's put a 17. And let's run our code and see if we can see our cube. Oh, there we go. So here is our cube. Hopefully you can see that. Let me go ahead and change the background color because it's kind of dark as well. So let's go inside our main app. Let me change this to some other color. Might not be a great color. Let me just put this to 9.9. So this way we can actually see things a little bit better. Alright, so here we go. Here is our cube. Obviously it's black because we don't have any colors for our vertices. And with that said, let's go ahead and load a few models and see if our code is actually can handle multiple items as well. So let's go back inside 3D Builder. So close this. And let's create a new scene, and I'm gonna add something. Let's add this keychain that we have here. Okay, so this keychain comes with 5 parts, and let's save this and see if we can load it. So let me save this inside here. Okay, and I call it keychain 3MF. And let's change the code. Okay, and let's try to run this. Okay, great. So we can actually see that we loaded all the keychain parts that we just saw in 3D Builder, and that's pretty good. Let's create another file and see. Let's do close 3D Builder. Let's create. Let me delete this thing. Let's bring in, I don't know, this guy. All right. So let's export this. So this is called rocket.3mf. And let's go back in our code and let's load this guy. Great. So it seems like that we are loading our 3MF with base materials fine. As you can see, the orientation is a little bit off, which is totally okay, and we are not also taking into account the transformation or anything. But other than that, we are actually able to load our mesh data and display it in our scene. Okay, so this should conclude part 7 of this video tutorials, and I hope you find this video useful, and see you in the next video. Thanks.